So one of the main things you'll have to discover or measure or calculate in this project is the speed of your car. All this stuff is kind of based on the motion of the car. So in the drawing here we've got a car running down a track that hopefully is marked off measurements. So if we're going to try and figure out speed or velocity, speed is defined as the distance the object goes and the time that it takes. So if you have this slow-mo video where you can see time and you can see location, then you have the ability to figure out both distance and time values for this car. So let's assume that your car has been released, you're watching the video back, and the car goes from this location that I've drawn it, and we'll say like you're using the nose of the car, that it's here, and you let a few frames of the video go by, and then you find that the car is now here. So what do? The nose of the car is now at this location, so you're going to have to figure out how much distance is that, and then based on looking at your timer over here, what was the initial time? We'll call it TI. What was the time that the car was at this location? And then what was TF? What was the time that the car is at that location? And then the difference in those times is your T. So if you put that into your equation here, the distance the car traveled divided by the time that it took to travel that far, that allows you to find speed. Now you're trying to figure out where in this situation your object had the top speed or the fastest speed. So assuming a car is running down a track, you'll probably have to redo these calculations a couple times. So maybe you let the video play forward again, and now your car has moved to this location, and so now you have another distance, and then you have to do another time, and you calculate speed again, and then maybe you do it even one more time, and you say, okay, the car has gone to this location, there's distance, there's the time. So you're going to keep calculating speeds. Now, when it comes to acceleration, let's pretend that you discovered that this blue section was your top speed, that you think the car was going the fastest in here. Okay? If you're going to calculate acceleration, acceleration is the change in velocity divided by the time it takes. Okay? Now, thinking about this scenario, if your car was released from rest at the beginning over here of your track, and then it moves into this location where you calculated the speed using distance and time, then its change in velocity has gone from this point where it had a velocity of 0 to this point here where the velocity equals your top speed. Okay, so the change in velocity is from 0 up to the top speed. So essentially the change in velocity is your top speed, because top speed minus 0 is going to be top speed. Then you need to divide by the time it took. The time it took to get from here over to this section. Now I would suggest you do the time at the center of that section, because the speed that you calculated is an average speed over that little chunk. So if you go to the center for the time, then that's most likely when it was going that speed. And then you'd use this time as the time that goes here. And you'd have an acceleration, speed divided by time. Now, once you have acceleration, you can bring that into the force equals mass times acceleration equation by plugging in mass and acceleration. A key little tidbit here, your mass needs to be in kilograms and your acceleration needs to be in meters per second in order to get the units of newtons at the end. If you don't have your mass in kilograms, or you're not currently in meters per second for acceleration, that's something that you can easily do, just like a Google unit conversion thing, and just do a little switcheroo with that. Okay, hopefully that gets you through the steps you need.